This review is all about solving equations and inequalities. First, we're going to look at what your possible solutions could be when you're solving an equation. So one option is you'll end with a variable equals a number. So for example, you would end with x equals 7. Another option is you could get no solution if you end with something, for example, 4 equals 7. We know that's not true, it's not equal, which means there would be no solution, which means there's no number that you could possibly plug in to the equation and have it be true. If you get all round numbers, you might end with something that like 7 equals 7, which we know is always true. And that means that you could plug in any real number, any number that you know about in your math career so far, and it would make the equation true. Next, we're going to look at the steps to solving an equation. First, you draw the Grand Canyon line down. You're going to combine like terms on each side. You would move the variable terms to one side and the constant terms to the other using inverse operations and the properties of equality. You're going to combine like terms on each side, isolate the variable by using inverse operations again, and then you're going to simplify and solve. And you always want to make sure you check your answer. So let's do an example to practice here. We have 3/5 times the quantity of 1 plus x is equal to 21 over 20. So first you're going to do the distributive property. And you're going to distribute the 3/5. So 3/5 times 1 is just 3/5. 3/5 times x is 3/5 x is equal to 21 over 20. Now you could go straight to subtracting the constant term, the 3/5, or you can go ahead and clear out all of the fractions. In order to do so, you would take the least common multiple of all of your denominators, so 5 and 20, which is 20, and you're going to multiply each term by 20. Doing this is going to get rid of your denominators. So if you multiply the 20 and the 5 here, we're going to simplify that so there's a 4 on top. Same thing here. There's a 4 left. And here we have a 20 on the top and a 20 on the bottom, so we can just cancel those out. So we're left with 4 times 3 gets us 12. 4 times 3x is plus 12x. And then we're just left with a 21 on this side. At this point, we're going to move our constant term, our 12. So because it's a positive right now, we're going to subtract it over and do the inverse operation. 12 minus 12 is 0. We're left with 12x is equal to 21 minus 12, which equals 9. Right now, x is being multiplied by 12, so in order to get it alone, you want to do the inverse operation. You're going to divide by 12 on both sides using the division property of equality. 12 divided by 12 is 1, so we're left with x is equal to 9 over 12, and you always want to simplify your fractions, so we could divide by 3 on the top and the bottom, and we're left with 3/4. To check your answer, you would plug in your answer back into where x is, so we have 3/5 times 1 plus 3/4. We're substituting that back in for x is equal to 21 over 20, and if you type that on your calculator, you should get true at the end, which shows that you did the problem right. Next, we're going to look at ratios and proportions. A ratio compares two numbers, it's a fraction. A proportion is an equation where two ratios are set equal to each other, and you want to solve those by cross multiplying. So for example, you might have the ratio 2/3 is equal to the ratio x over 6, so that's a proportion. And in order to solve that, you would cross multiply, meaning you're going to multiply a numerator and denominator, so 2 times 6 is 12. And then you're going to multiply this one, 3 and x, and you would get 3x, and then you would go ahead and proceed and solve for x. In this case, x would equal 4, and so this proportion is saying 2/3 is equal to 4/6. Another example says, express the following as a ratio. A car is traveling at 60 miles per hour. Anytime you see that word per, that indicates it's a fraction. So you would be going 60 miles per 1 hour. And that's how you could set up that ratio to represent that scenario. The next topic we're going to look at is literal equations. This is just when you rearrange equations to solve for a specific variable, so which means you get a variable alone by using inverse operations. It's the same exact process as solving an equation. There's just usually a lot more letters, a lot more variables involved, so sometimes it looks more complicated. In this example, it says solve the following equation for x, which means you want to get x alone. Right now you want to think about what's happening to x the same way that you would if there were numbers involved. Right now it's being multiplied by c and d is being subtracted. So first we would cover up the cx and we want to move that negative d. So we're going to add d to both sides. You're left with cx is equal to, now r and d, we don't know what those are. We don't know if they're like terms, so we're going to keep them separate for now. So cx is equal to r plus d. Then again, you always want to ask yourself what's happening to x. Right now, x is being multiplied by c, so we're going to divide each piece by c. And we are left with x is equal to, again, we don't know what these terms on the right side are. We don't know if they're like terms, so we're going to leave it as is. R divided by c plus d divided by c. So the goal, if it ever says solve for x, you always want to make sure you get whatever variable this one is alone. Next, we're going to talk about word problems. We're not going to do an example here, but just go through the steps. First, you want to read the problem and take notes while you do that. You can underline, box things, draw little pictures, whatever. Next, you're going to determine the variable, figure out what you're looking for. Remember, variables represent unknown values. If a picture is applicable, draw that. If it's talking about length and width, or a square, or a rectangle, anything like that, make sure you draw a picture. That'll help. You're going to write out your other variables in terms of the first one. And then you're going to write an equation and solve your equation. And then always make sure you actually answer the question. And depending on what the problem is, you want to make sure the actual answer makes sense for the problem. If it's talking about a number of people, make sure you don't have a negative number or anything along those lines. Now we're going to switch gears and we're going to look at solving inequalities. Solving inequalities are very similar to solving equations. The solution to an inequality is a number that makes an inequality true. There's 3 ways to graph your solutions. The first is to graph it on a number line. You want to remember that if you use a less than or a greater than, you're going to use an open circle. And if you have a less than or equal to or a greater than or equal to, you're going to use a closed circle. So we're going to use the example x is greater than or equal to 4. So you would draw your number line. My rule of thumb is you always want to have 3 reference points on there. So you start with your number in the middle, so our 4, and then you got to go 1 below and 1 above. Now all of the answers or the solutions are numbers that could be greater than or equal to 4, because it could be equal to 4, meaning 4 could be a possible solution. We're going to put a closed dot there, and then everything else would be to the right of it. And you can always check by plugging in a number. So for example, if we wanted to plug in that 5, 5 is greater than or equal to 4, so that works. The second way to write your solution is with set builder notation. You always want to start with a funky bracket, and then x, and then this line right here means such that. So you would read that out loud as such that. So x such that, and then you put in your inequality. So for our example, x is greater than or equal to 4, we would do funky bracket, x such that x is greater than or equal to 4. It's kind of like you're naming the variable there. The third method of writing your solution is called interval notation. You would use parentheses and brackets. Intervals mean between two different numbers. So for example, for x is greater than or equal to 4, all of our possible numbers have to be between 4 and a positive infinity. So you would start with your interval, and you're going to write down your 2 boundary points. So 4 and positive infinity, you always want to write them in order from least to greatest. Now it says whenever you have a infinity, you're always going to use a parentheses. And then with the 4, because it's inclusive, meaning 4 could be a possible solution, or you have a greater than or equal to, you're going to use a bracket. So this is saying all of my answers have to be between 4 and infinity, and 4 is included as a possible solution. So notice that the symbols, the parentheses and the brackets, do not have to match each other. They always go with the number that they're talking about. So for example, this bracket has to do with this 4, and this parentheses has to do with this infinity. So you can always have different ones, and it always depends on what the number actually is. Last, we're going to look at how to solve inequalities. To solve inequalities, you follow the same steps as with equations. You always want to move the constant and then get a coefficient of 1 for the variable that you're solving for. The only exception, and this is a big deal, so I'm going to kind of circle this in red here, is you want to remember that when you multiply or divide by a negative number, you must flip the inequality symbol. So if you started with a less than, you're going to flip it to a greater than, or vice versa. If you start with a less than or equal to, you're going to flip it to a greater than or equal to. So let's do an example. Negative 2x plus 1 is greater than or equal to negative 7. You're going to draw a Grand Canyon line. We want to move the constant first, so we have a positive 1. So we're going to use the inverse operation, which would be subtracting 1, using the subtraction property of equality. We're left with negative 2x is greater than or equal to negative 7 minus 1 is negative 8. Now to get x alone, x is being multiplied by -2, so we need to divide by -2 on both sides. Because we're going to divide by a negative, we're going to flip that sign. So instead of it being a greater than or equal to, it's going to be a less than or equal to. And then we can continue out. -2 divided by -2 is just 1, so we're left with x is less than or equal to -8 divided by -2 is a +4. And let's practice writing our solutions in the 3 different ways. So first we're going to do graphing. So we're going to set up a little number line. We've got our +4 in the middle, our 3 and our 5. All the solutions are less than or equal to 4, so we're going to use a closed circle on 4, and we're going to draw our arrow going left. Always make sure that your arrow makes it obvious which direction the solutions go in. Then we're going to do set builder notation. So we're going to do funky bracket x such that x is less than or equal to 4, and then interval notation. If it's less than or equal to 4, all of your answers have to be between 4 and -infinity. So to write it in order, you would do -infinity first, +4. With infinities, we always use parentheses, and 4 is included in the solution because 4 is less than or equal to 4. So you're going to use a square bracket there. So that is our review for solving equations and inequalities. Some of the major things that you want to make sure is you know how to solve an equation, and make sure you know how to do that with fractions and decimals. That's huge. Those will definitely be on the exam. Literal equations, there are always problems like that on the exam, so make sure you practice those. Obviously, word problems are big. And then solving inequalities, you really want to make sure that you remember this rule right here, that multiplying or dividing by a negative number, you flip the sign.